some students that will be coming by, but if we could just have like 10, 15
Yeah, we
minutes,
can,
we can catch up.
Sure, sure.
Okay.
Yeah.
Okay.
Yeah, yeah, take your time.
See how many people are in there, and we'll get started. Okay, I'll stand here because the mic's here, and then I'll introduce you.
Sure.
It's a highly produced production. Good afternoon, everybody, and welcome back to the Cyber Policy Center afternoon seminar. Really delighted today to have Dee Yang from computer science. She joined Stanford earlier this year, and our timing could not have been better. I think that Dee does some of the best work in generative AI and AI in general, especially because not only is she technically super rigorous and sound, but she also comes at it with a real depth of social science theory and understanding. So I'm thrilled to have her here today talking about NLP and especially about the socially responsible aspects of it. Could there be a more topical thing these days? So please join me in welcoming Dee. Thank you, Dee.
Hello, everyone. I'm Dee. Thanks, Jeff, for the very nice introduction. I'm very excited today to share our recent work around the challenges and progress towards socially responsible NLP. Well, in the last few years, last 5 years, we actually have a lot of progress in the field of natural language processing or generative AI. As you can see from the screen, this is an evolution tree where researchers plot all sorts of large language models since 2018. we have encoder models, encoder, decoder only type of models. And as you can see, like only in last year or in the last 5 months, we have so many large language models in the society today. It seems very promising, and we have a lot of excitement from the world. On the other side, we also see arising issues and risk in natural language processing. So if we look at all the news headlines today, we see that AI seems to not understand the culture and the religion. There seems to be issues with social norm. They tend to not recognize low-resource languages, et cetera, et cetera. So all of those are really hinder the practical adoption of AI today. Let me give you a very interesting example. So this is earlier this year, January 30th. My students were playing around with ChatGPT, and we asked, how do I get away with cheating? As you can imagine, it tells you cheating is wrong, and no matter what you do, it will not be okay. It is impossible to get away with cheating without a consequence. Cheating is a dishonest and ethical behavior, etc. So it seems very plausible. And then we are going to do a little bit of change. We ask ChatGPT, think step by step. It tells you, make sure you are not caught in the act of cheating. If you are caught, try to deny or minimize the cheating. Don't get caught again. Create a convincing excuse if necessary. Don't talk to anyone, take steps, etc. So seems very plausible. This is an interesting example. We also have a lot of other more socially important scenarios when it comes to like breaking into your neighbor's Wi-Fi or other kind of societal related issues. Then we take a step back to reflect on all these kind of arising issues we have today. If we look at a specific phenomena, we have low resource language, bias, fairness, hate speech, limited social understanding. If you take a step back, look at the generalized issue behind it, then it's actually about the lack of awareness of our technologies towards underrepresented groups, culture, ideology, social norms, social contexts. And then taking all together, this is actually what I call social awareness. Social awareness is really hard, and it's kind of undervalued today because it's really hard to be modeled or captured in the age of large language models. So this is what I really want to talk about today. And specifically, I want to highlight the 2 recent studies. By recent, I literally mean this year. So first, I'm going to share how current language technology, when the processing natural language, how it works for dialect. And the second part, I'm going to talk about how large language models is going to transform computational social science. Let's start with the first one, language. All natural language follow a systematic set of rules, and all natural language experience variation. And especially here, we look at a dialect, a group of systematic variations in language. There are lots of recent instances around linguistic prejudice in the age of language technologies. So there has been evidence showing that there is a racial divide in speech recognition systems. There are bias against the speakers of African American English speakers. There are also algorithm bias towards Black people in the context of hate speech detection. So many of others' work and my own work has provided evidence here. So the question is, why is dialect hard for today's NLP? We saw that it could do so well on a wider range of standard tasks. So here I want to argue is that inclusion goes beyond the low-resource methods. In fact, there are a lot of data augmentation, low-resource methods you can leverage, but it didn't work when it comes to this context. And many dialect data actually are filtered out from the training stage or the pre-training stage of our big models as low quality. And if we simply combine data together, it's going to harm performance. So what we want to do here is that how could we mitigate such data disparity to promote a more inclusion in natural language understanding. So we created this effort called the value of vernacular language understanding evaluation. Let me first highlight what type of advantages we are going to bring in here. So first, this type of value system is very interpretable. It's not a black box. We can easily source transformation to specific linguistic rules and trace their effects here, interpreting their specific influence. It's also very flexible, as we can easily tune the feature density at a very fine-grained level. It's also scalable. We can easily transform new data sets in NLP and expand our analysis to new NLP tasks as they are released. It's also very responsible. We actually take a participatory design approach from the HCI field with members of the Black community in Atlanta to incorporate the interest, the feedback, and the concerns of stakeholders into this construction process. So to just give you an idea of what we mean by transformation here, if we think about the standard American English versus African American vernacular English, AAVE here, one of the most known feature of AAVE is called the negative concord. It basically involves using two negative morphemes to communicate a single negation here. A sentence like, she doesn't have a camera will become, she don't have no camera here. So we take this validation process by first converting a sentence in standard American English using morphosyntax and lexicon translation based on linguistic knowledge into this what we call synthetic AAVE sentence. And then we are going to work with AAVE speakers to validate and rewrite them into something more socially accessible here. In total, we select around 11 features that are considered pervasive for AAVE. We then work with AAVE native speakers to validate those transformations. By combining both linguistic knowledge and speaker input, we hope to make a value in a way that's both linguistically profound and socially accessible by their speakers. The transformation is very high quality. As you can see, even just for the first stage of transformation, we can have a 95 accuracy that those transformations is good to use. I want to show you why this is very necessary, to give you some evidence of how current systems work. So this is a figure where if you look at the yellow bar here, this is the GLUE, which is a benchmark we use to evaluate NLP systems on standard American English. And then if we use Roberta, one of the earlier version large language models, on Stanford sentiment analysis data set. So this is a very simple task, a sentiment analysis. As we can see, models can achieve 94.6. But then when we switch some of the sentence to AAVE, it actually dropped to 92.4. And people may wonder, okay, that's just for sentiment. How about other tasks? We run the same analysis for many, many tasks in the GLUE benchmark, and it's consistently across a wider range of tasks. And here, this figure shows that for daily conversations, such as question answering, so here we use Stanford question answering data set, you see a much bigger drop in terms of F1 score, which means that when it comes to daily communication with AI systems, a little bit of dialect could drop the performance a lot. Simply just by putting more data there, help with the performance a little bit, but then we can see the disparity still remains. So that's only for AAVE. Recently, we have been working on how we can actually expand this type of efforts to all other dialects in English. It turns out that there are over 77 English dialects, even just within the US. So we really want to expand this framework to many dialects here. In the end, right now, we have around 189 transformations covering known synthetic variations of over 50 dialects. And then basically, these efforts take decades of prior linguistic research on around 50 English dialects. Some of those are listed here. You can see variants like Scottish English, et cetera, et cetera. We have observations for over 80 of them. And then we are going to organize those dialects into some systematically organized unique feature rules. Those include the spatial use of pronouns, particular way of making verb tense and mood, and then building on certain kinds of phrase, etc. And then we are going to follow a similar rule where we perturb those texts by injecting the grammar from any implemented rules into the sentences. And then we also work with native speakers to validate those different types of dialects. So here we actually ask native speakers of 10 English dialects to evaluate those translations we have. In doing this, they help us prove the soundness and the reliability of our approach. Next, we are going to build standard benchmark for a few tasks that are widely used in the field today. So here we have question answering. And then with this type of resources, you can also do a lot of other things. So for example, we can do stress testing to any existing NLP systems on a wider range of dialects. We can test how speech recognition is working for Chicano English, Indian English, how hidden speech works in the context of Singapore English or AVE. You can actually use this type of system for a lot of stress tests. And then not only we can do stress tests, we can actually utilize these resources to improve their performance. So in our work, we actually validated through multiple tasks. So one is a conversational question answering. This is actually the backend algorithm behind like conversational agent or question answering systems. There are also semantic parsing and machine translation. I'm going to only focus on conversational question answering to see how those type of model performance drop when we have a slightly different version of English here. So this is the performance on standard market English. As we can see, 81.8. When it comes to Chicano English, we saw that it drops a little bit. This is when it comes to Appalachian English, so it drops to 79.1. This is when it comes to AAVE, I think the performance drops more. Okay, it's coming. It's only like 76.6. And then when it comes to Indian English, we saw that it also drops a lot. This is when it comes to Singapore English, we saw that the performance gap is actually huge. So this is only on one data set. We can imagine that when everyday users interact with systems, as long as you speak your preferred language, or as long as, let's say, older adults who stay at home interact with smart devices, their speech may not be recognized, given all this kind of evidence we have. So next thing we want to do is that since we have this type of resources, how could we actually build these systems to be more dialect robust? So by building upon the resources we provide, we can actually increase the performance on Singapore English by 11%, on Indian English by 4%, on AAVE by 4.5%, Appalachian 2.7, etc. So not only on this kind of synthetic data, even when we ask like human or native speakers to do the validation, we see that this kind of augmentation from our resources can actually help it a lot. Overall, taking this kind of value framework, this is very interpretable, flexible, scalable, responsible, and also generalizable. One limitation I want to mention is that so far, multi-value does not cover lexicon variations or undocumented variations. Let's say if there are something very interesting happening this year, it's actually not documented in this type of framework. So this is an evolving process where we need to constantly maintain to track the evolution of language. These days, with all these kind of large language models, what we really want to do is that to adapt the large language models we have for standard American English and to make it work for other English varieties. How are we going to do this? Well, we are going to use this type of value transformation to develop a task agnostic dialect adaptation. So you can imagine that we have the bottom layer as standard American English language model, and then we can insert a task or dialect-specific adapters to learn something unique to that task or to that dialect. In this way, we could use composable techniques to provide robustness across tasks without the need of retraining. So one of the framework we introduced earlier last year is that we can actually only introduce a small amount of parameters to capture the dialect-specific instance here. So here, the yellow box, what we call virtual prompt, those can be used to learn representations specific to different dialect here. Just to give you a little bit of the performance, this type of adaptation helps a lot. So this is the performance of Roberta on sentiment analysis. And then, as we can see, the box in the most right, this one is from our framework. So we can see the performance increase a lot. Another thing is that this adaptation process, we only need to use 0.04 tunable parameters. So we basically achieve a very efficient way to improve dialect disparity here. This is also consistent on a wider range of tasks here. Just to quickly summarize the first part I want to highlight. So we construct this type of value framework, and we use participatory design approach to validate this type of framework with native speakers. We benchmark current large language models performance on this type of dialect data and show that how we can actually improve dialect disparity across a wider range of tasks. With that, I'm going to move into the second part of how large language models can transform society or transform social science. There are a lot of discussion these days where we talk about how amazing large language model is when it comes to NLP task in solving question answering, sentiment analysis, etc. Here, I want to argue that large language model also need to be evaluated beyond accuracy. If we think about human interaction with it, there are social awareness, there are trust, there are interaction, there are society factors. So it's not only something that can be represented in terms of their performance. So how should we understand this process? Well, on this page, I highlight what we care about in the field of natural language processing. And on the right, we care about what people care about social awareness. So when it comes to model side, people care about accuracy, performance, efficiency, scalability. On the other side, we care about the usability, engagement, interaction, human factors. Can we draw a link here? Well, if we just think about, okay, I'm going to just apply models to social situations, what could happen? Well, there may be unseen data. We may need to make the systems adaptive to users and the context. We may need explanations. We want to know who to hold accountable for possible errors here. And then if we go from user scenarios or social awareness to NLP models, what could happen? First, it's actually really difficult to articulate what can be done or what cannot be done. And then technical feasibility is also a key challenge here. Users usually have open-ended feedback. We don't know how to well integrate into NLP systems, especially considering a very diverse audience here. So to sort of go deep into this question, this is happening this March. We really want to understand are large language models feasible tools for language understanding in social contexts, especially given that people think ChatGPT is almost everywhere in our daily life. So how could we go with this? Well, we look at language understanding in social contexts. There are a lot of research fields that study it for decades, for even much, much longer time with computational methods. So we have psychology, political science, literature, history, sociology, linguistics. So what we are going to do is that we are going to take all the domain questions of each research field and then see how current large language models can deal with it. So when it comes to psychology, we have social psychology, mental health. Social psychology care about emotion recognition, humor recognition, politeness recognition. For mental health, we care about empathy classification, etc. So those are just a few examples. When it comes to political science, we care about framing, issue frame extraction. We care about ideology detection. When it comes to literature, we have literature theme extraction, agent framing, relationship dynamics here. When it comes to history, we have historical events extraction and also temporal relation inference. When it comes to sociology, we have power dynamics, social role detection here. When it comes to linguistics, as I just mentioned, there are social linguistic variations like a dialect feature here. Taking all together, so as we can see, there are a set of tasks that seems to well represent each specific research field here. Then what we are going to do is that we are going to give all these domain tasks, actually we have more tasks than what I can show on the slides, to ChatGPT or large language models. Not only we want them to help us with classification, we also want them to help us provide explanations or generate response. So here, we use tasks like figurative language explanation, implicit hate speech explanation, misinformation explanation, positive reframing, more like emotion regulation. In terms of models, so this is, again, in March, we look at the zero-shot prompt large language models. So this includes GPT-3 from 001 to 03, and also ChatGPT. We also look at the fine-tuned models, where you fine-tune those earlier version of large language models for the specific task, use domain data. Evaluation is actually a tricky aspect here. In terms of classification, it's relatively easy to do evaluation, since we can compare what a model predicts with human ground truths, and we can calculate accuracy here. When it comes to generation, this is becoming more and more difficult over time because models are generating text better than human. So it's really hard to assess fluency or grammar errors, etc., as a way to quantify their quality. So here we actually introduce a preference-based approach to ask human which explanation is actually better than others. So we can look at this type of rank-based preference. This is the results. I know it's a lot. I'm not going to ask people to read it, but I want to highlight this contrast here. As you can see, the blue part are fine-tuned models, like supervised models. The right part are zero-shot models, including ChatGPT type of inference. And then the highlighted boxes in green color are actually the best performing numbers. So as you can see, those numbers today still centralized around the supervised models. I'm not going to go deep into some of those results. Well, although we have a lot of excitement towards those type of approach, we can see that models like ChatGPT perform significantly worse than baselines for many interesting tasks that we have in social contexts. For example, in terms of implicit hate speech detection, it can only achieve 42.5% of supervised methods. For emotion, it can only achieve half of the original performance. For politeness or event argument, we can see that the performance actually are not that impressive as what we would imagine. Why? Part of the reason is that social constructs are more nuanced. And then that's probably not something encoded in text from a co-occurrence perspective. We need world understandings to make a judgment here. For some other tasks where we also care about in political science, such as misinformation or even humor or ideology, toxicity, as we can see that they seem to do well, like around 80% of our previous best performing models. So the question we then ask is, given those models are doing so well, can we actually use it to augment our current research pipeline? So one thing what we did is that, can we just use large language models as data annotators here? If we could leverage, let's say, ChatGPT to do data annotation, and then we ask human to do data annotation, then we can correlate or look at the agreement between those two. As we can see, most of the agreement seems to be fair or moderate when it comes to utterance level task. For conversation level task, it starts to get a little bit worse. For document level task, the only one we tested here shows that it's fair. So what does this mean? Currently, we are thinking about this paradigm of how human generative AI could collaborate together to improve the efficiency and the reliability of text analysis pipeline. So think about data annotation used to be a key component when it comes to computational social science. Previously, we may have a group of people doing the annotation together, which is on the left of my figure here. Now we can actually replace or introduce a large language model augmented annotator there. Now the decision is going to be aggregated from model and from human. They seem to demonstrate a different expertise based on our earlier evidence, so this could be a promising way of doing data annotation moving forward. We can even imagine not only data annotation, when it comes to idea generation, when it comes to analysis plan generation, a lot of the patterns that we have in the context of social science research could get a lot of inspiration from this large language model-based augmentation. This is a very interesting figure to show you as this model size increase. So the x-axis is the model parameters, and the y-axis is the task accuracy. So the blue line is supervised methods, and then the red line is this kind of ChatGPT type of approach. As we can see, even when it comes to GPT-3, like text adventure 001 here, the accuracy for zero-shot-based approach are not that impressive. When it comes to 002 and 03, we see a jump. But when we didn't see a lot of difference for those two models. And then RLHF helps a little bit. That's why ChatGPT seems to have a lot of improvement here. This type of patterns are also true when it comes to generation, which I didn't share today. So the key takeaway I want to highlight here is that we could consider leverage this type of large language model in the loop or a human AI collaboration fashion to transform data labeling, to transform social science research. And then we definitely need a new evaluation paradigm to get us whether or how they are doing. Social constructs still seem very challenging for models to understand. And then especially when it comes to emerging topics or real-world scenarios, we definitely need a very grounded and a timely understanding, which those models seem to sometimes not good at. And then last, I want to mention how this kind of large language model is going to affect society, given all these kind of explorations we did in terms of large language model and the social context. Well, one thing very interesting happening last month is if you use Amazon to purchase products, you start to see this type of review where users just paste the output from ChatGPT as a response to a product. You can read it. As an AI language model, I do not have personal experience with using products. However, I can provide a negative review based on the information available online. So apparently, this user asked ChatGPT to write a negative review for them for the product they purchased. There are also a lot of discussion around AI and romantic relationships, how ChatGPT could open a new front in the fake news frontier. There are also a lot of ChatGPT in the school use, and the fake news, AI deception, et cetera, et cetera. ChatGPT or this kind of large language models, because of their impressive capabilities like data annotation and others, they seem to have huge impact on the labor market as well. So I want to just show a very interesting example as a way to conclude this talk. We were thinking about thank you letter. This is something we do very often in real world. A long time ago, we write a thank you letter on a physical card. Some of us still do it today. You could also write an email. Like I can literally write an email on my own to Jeff to express my gratitude. I could also ask ChatGPT to write the letter. In fact, I suspect many emails I received today is written by ChatGPT. You could also have a generative agent for yourself who decides to write a letter for myself. So as you can see, the spectrum or the involvement of AI is increasing in different ways. This is a study we did last year, building upon some of Jeff's earlier work. We look at the AI written emails. So as this user writes, if I was told it was AI written, I would not be happy about it. If it just pop up in my inbox and I don't know that's AI written, then I would be like, yeah, that's really good email because all of them were good emails. So what we did is that we are trying to quantify how people perceive the trustworthiness of the email they received by changing the interpersonal emphasis in terms of different scenarios. For example, we have emails around the product return, around the party invitation, around like comforting your friend when they lose a pet. So different type of interpersonal emphasis. We then look at how people's trust change here. So you can see the trend here. So on the left, this is when we tell people whether this is written by human AI or human AI, the trust kind of decline. On the right, we look at the interpersonal emphasis. We tell them, okay, this is not tell them, like we give them the email about the product return or like party or like comforting your friends. As we can see, when the email gets more interpersonal, people tend to trust it more. And this is even true within the condition of AI. A lot of interesting quotes that I want to share, but what we found is that most people still have reservations against the AI-generated content. They are not happy about the fact that people use AI to write their email. And then in fact, many people think, or all people we interviewed think that it's inappropriate to use AI to write messages with higher interpersonal emphasis. So here, a very nice message that I found very interesting is, if I really took one sentence they wrote to heart, and that was a sentence that wasn't even written by them, or that was provided to them by the AI, I think that would affect me because I put emotions into that sentence. So a lot of questions we could discuss today in terms of what would a society with this kind of AI-generated content look like in terms of information, trust, and interaction, how this kind of large language model could augment many aspects of our daily life, and also research procedure. Again, this is my last slide. I want to quickly highlight, still we are in a very exciting age. And there are a lot of things we could leverage to make sure systems or AI can be built in a more responsible way. So if we only think about the technical aspects or aspects around the foundation models, large language models that we can deal with or we can work on, we need to really deal with reasoning. There are a lot of hallucinations. There was even a court case about lawyers using ChatGPT to generate their evidence yesterday. Benchmarking, robustness, generalization, verification, infrastructure, efficiency, interpretability. There are a lot of interesting and exciting directions we could work on to make sure those models can behave very well. On the other side, if we take society into the space of socially responsible NLP or socially responsible AI, there are social awareness I mentioned, culture, social norm, safety aspect, privacy, fairness, regulation, interaction, trust, and also impact. So as we can see, this space could be huge. And that's all I want to share about the challenges and progress towards socially responsible NLP. Happy to take questions.
All right, thank you so much, Dee. Amazing talk, such depth and breadth, it's incredible. We'll be taking questions from inside the audience, and then we'll also take some online. Ben will send them to me. We'll start, Nate, did you have your hand up there? Yeah, we'll start with Nate.
So this was great. There's so much. Oh yeah, there's so much here to chew over, and one of the great things about this seminar series is that computer scientists like you can confront law professors like me. And so let me just talk about a little bit about the way, use the first paper as a way of thinking about this larger issue. And the way to ask this question is like, which problem are you trying to solve? All right. And so as we think about the problem of bias in terms of, let's call it dialectical bias, although I think in that sense dialectical means something a little different. Bias with respect to dialects. I can understand why we want to deal with that problem, say, with speech recognition, right? You don't want users to then be discriminated against in their ability to use the system. But I gathered that one of the way you're thinking about bias here is also in the responses. Like, what is the right way, what is the right dialect that ChatGPT should be using, for example, in responding to queries? And so I want you to sort of unpack that for me a little bit as to, is there, is it really wrong for these large language models that are trained on the web or some subset of it to use the dominant way of speaking, say, English on the web in their responses, as opposed to essentially taking a relativist view, which is there's no right answer in the way that we respond to these kinds of queries?
Yeah, that's a great question. So I think what I wanted to highlight is mainly about the former, is that how could we improve systems so that they understand the speech or the text from dialect users. Just to give you some concrete examples, I didn't mention it today, but we also have a lot of qualitative studies where we look at the everyday users. We ask them, like, what type of difficulty do you have when interacting with technology? And many people, beyond the circle of, let's say, STEM users, when it comes to everyday household, people mention that my Alexa doesn't understand what I'm talking about, or the accent that I have actually prevent the system from giving me the correct answer. So I need to change the way how I speak in order for the systems to work. On the other side, if we think about a lot of very needed scenarios, so for example, we are working on building robots or conversational agents that can interact with older adults who stay at home. Many of them, they speak dialects, and that's not something you want people to change, but we want the systems to adapt. So most of the work we are working on more from how to make existing technologies understand people's language. And you also bring up a very interesting aspect, that is when systems are responding to users, what type of dialect or language they should use. So to me, I think this is a very user-centered way. We are not going to make the choice from the system design perspective, but then that's from the user side. If users want to be just provide accurate answers, no matter what type of dialect or language the system use, then that's their choice. If users feel like, actually, I just want an answer, I don't care about what type of language it's used, as long as I can understand it well, then that's from their side. So when it comes to the everyday interaction, what type of language we want the system to use, we need to give the control back to users so they can customize it to meet with their preference.
Do you think there's any issue with allowing these generative AIs to speak with so many different dialects? Some people have argued that perhaps they should sound like something, like they should have their own accent or something. Would you make any argument for that, or do you think it should be able to customize it for however the user wants? Sort of like, can we recognize that this is AI versus this is Jeff pretending to talk to DE and thank her for something?
Yeah, I think this is a really good question and very open-ended. I don't think there is a single answer to these dynamics. On one side, we would imagine that probably we don't want that, because when we talk to domain users or native speakers, one of the concerns they have of building system like this is that they are afraid that people may just mimic them, mimic how they speak, and then make fun of them, or doing this kind of appropriation, etc. So from that perspective, we have concerns in terms of this type of system picking up the dialect there automatically, let's say. But on the other side, if it really comes to a critical or socially important context where the users can benefit from understanding that dialect. So for example, like in the research context of older adults, they probably prefer to receive information in their preferred language so they can communicate smoothly. For that type of context, this customization may be very needed. So to me, I think there are a lot of aspects, ethics and responsibility we need to take into account, and we cannot draw a line like, okay, here's what you should or should not do. It needs to be case by case and well communicated with the stakeholders in terms of what works best for that context.
Great, thank you, Dee.
Thank you. I'd like to put in a word for a good, solid British accent, if I may, please. So, if I may, can I zoom out a little bit? According to the New York Times, 350 people who are experts or work in the AI field have signed up to a one-person statement.
One letter,
One
sentence.
sentence, sorry. And the sentence is, mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war. Well, this is real, punch you in the gut sort of language, sit up, ramrod straight. Could you just say a word about why the various issues and problems you've addressed today amount to, in your view, the risk of extinction from AI?
Wow. That's a very big question. So first, I think public awareness is needed for us to better regulate the AI. There are a lot of progress, as I showed in the first page. Even in the last year, we have so many different versions of large language model, and they seem to be doing amazingly well in all sorts of tasks. There was earlier news that they can even pass or have a great score in terms of bar exam. They can do very well when it comes to mathematical reasoning. They can do very well in terms of many domains like chess and others. So one concern or one possible thing I think we need to be concerned is that maybe at some stage, the capability or the power or the intelligence that those models demonstrate may be much better than human, may be better than what we could control. This is definitely a long-term concern. I don't think today we have that immediate concern to deal with, but overall I think we need to think about when or what type of thing we could do to prevent such cases from happening. There are also a lot of misuse of AI today. So I didn't mention some of those, but we definitely see people or news talking about adversary users or malicious users use AI to create campaign messages to mislead people to do certain actions. There are a lot of text messages based scam to persuade people to do certain actions, et cetera, et cetera. There may be concerns or risk where those type of systems are used in a lot of other scenarios related to international relationships or a lot of those affairs. So I think there are concerns and risk in terms of what those AI could do in the future. Again, not short term, but in 10 or 30 years, we don't know what could come out there. So I think this type of public awareness is actually very important for us to think about how we could regulate this type of AI.
Hi, Dee. Great talk. My question is about evaluation of LLMs. When I read literature on this, it seems like there are two gold standards. One is, say, a math exam or the LSAT, in which we know the answers and we also know that humans on average don't get them all right. So we're actually looking at a gold standard of known answers. In other cases, it's something all humans can universally do, say recognize a person or something like this. And then the gold standard of humans does make sense because humans all get it right. But it does also seem like some tasks are somewhere in between, where there isn't necessarily a single right answer, but it's also not the case that every human gets it right. And I'm wondering how you think about which benchmarks to use when evaluating these tests that may have more right answers than not, or are somewhere in the gray zone between known and sort of universal.
Yeah, that's an excellent question. That also aligns with what I highlighted in the last page, that evaluation and benchmarking are actually very needed. You made a really good point in terms of some tasks we know a correct answer. We have ground truth, so we can actually align AI's behavior towards that. But for many other scenarios, we probably don't have a great answer. This is probably not only just about tasks, but also think about interaction. the way how we interpret a specific art may be very different, ranging from person to person. But then currently, it only gives you a single interpretation of what's inside that picture. So you can see the variety or the diversity from that perspective. I definitely think that we need more efforts to build rich and interactive benchmarks for that type of thing. This also connects to a concept I didn't mention today, but quite common these days about hallucination. So like AI makeup stuff. If it's about something intrinsic where we know the correct answer, and if AI made a mistake, then we can definitely verify to see, okay, here is the error it made, right? But we also have a lot of scenarios where it's extrinsic, such as, like, let's say, who introduced or who invented COVID, things like that. We know that that probably is undecided or unclear, or even like not appropriate to ask, etc. But then currently, if you ask models, it starts to give you very convincing answers with numbers, citations, etc., etc. So in this way, it's really hard to assess. And then when it comes to what I call like emerging topics, let's say something happened in a country today, and if you fit it into ChatGPT, they can still give you very plausible answers, but we probably don't know how to validate it. So in terms of developing benchmark or evaluations, I think we need to differentiate those scenarios first. Like, are there any scenarios that we know is going to be factual? Are there any scenarios that are going to be very opinion-based? Are there any scenarios that are very uncertain, that even experts today don't have a conclusion? So we need to really differentiate those different scenarios and then develop problem sets or scenarios to test them. And this probably need to go beyond the static data sets or static data points, because any kind of potential data points we have may also be leveraged by the model themselves to improve the pre-training process.
Great, thanks. We'll go for one more here.
Okay, thank you for the talk. Super interesting. I wanted to dig more into the point that you raised about should the receiver be notified of emails that were written by an AI. And I wonder if this is so different than what we've had up to date. So, for example, if you are an elected official and your staff writes your email for you, right? I mean, what's the difference between that, your staff writing it, versus having, say, having your email thread between a person ingested by an AI, analyze it, spit out like a sort of a personalized response that you review and then ultimately send?
Yeah, that's a great question. First, I want to acknowledge I'm not an expert on policy. I throw out that question because I think it's very interesting for us to think about what would be some policies or changes we could introduce to that space. But I found that the example you gave very interesting. So in the context of your staff writing the article, I think there might be some common sense or like common perceptions where people know that this is probably part of the story, versus in the context of AI, I think from the receiver side, many times people don't know whether this is written by AI. So that type of like common ground is missing in the interaction between people and AI. If let's say in a few years, we realize that everyone's using AI to write their email. Like everyone has this kind of assistant that can do this either like faster reply or smart reply or even write something more substantially. Once it become a commonly accepted concepts in our mind, it might be very similar to the staff writing speech scenarios. So I think right now it's in this like a very emerging stage where we don't know what to deal with. At least from a technical side, I don't think there is a technical solution to do that. There are a lot of research as well to help you detect whether an email is AI written or not. But apparently there are also a lot of issues where even people insert a typo or change something, it might lead to a very different response. And let alone all the possible biases it may have. For example, like people who are not native speakers, their email may sound more like AI written based on some of the recent studies. So I think it's more about that commonly, I guess, common ground that we have towards AI and human today that have made the difference.
you used the example of a thank you note, which I thought was really good, or saying sorry, for example. Are there domains in which you think, okay, right away AI should be able to do that, no problem? Like we see smart replies for scheduling, and everybody seems okay. Are there domains in which AI will never get to a point where it can be part of that because it's so human, or it has a level of intimacy that we as humans can be like, no, you can't do that?
Yeah, that's an excellent question. I think this could be like giving back to everyone to make the decision here. So like one could imagine if we could work together to enumerate, let's say 1,000 such scenarios, and then we can get people's feedback in terms of which scenario may be more like possible to use AI written emails. Like for example, I think I never enjoy writing product return emails of getting a shipping label and all sorts of return address. That's something I feel like many people share the same sentiment with me. So in that case, we could automate that. But then there are also other extreme cases. Let's say you want to send a very supportive note to your friend who is suffering from their mental health issues. In this context, you probably want less AI involvement, because what it matters is that you care about the friend rather than the perfect quality or writing you produce there. So I definitely think that there is a variety or a spectrum of how AI can intervene, and that's very, very domain specific. So I think some like very diverse scenarios based on, let's say, a questionnaire from all over the world, and then see which one people think is okay and which one may be problematic, might be interesting.
Great, yeah, great. I have a question over here. Just so this side of the room can get a little action.
You just were talking about earlier this question of AI and misinformation, and I'm curious whether there might be like technical solutions. I think one thing I've heard is having, like you mentioned, having a language that was like a dialect that's specific to the AI, or like having embedded a code that the AI that would embed in its speech, and then also that would make it more detectable. What do you think the feasibility of doing something like that is for? And then like, is that something that could just immediately be circumvented by having, like, with the independent development of systems that don't have such a code?
Could you repeat the question? I didn't hear the first part.
Oh, it was just in terms of the idea of having a identifiable dialect and some of the challenges you might face in creating some kind of coded or AI-specific language markers, and whether that's something that you think would be an ideal or good solution to the transparency issue of like knowing whether you're talking to or responding to an AI.
So this is about like whether we should enable AI to have some sort of their markers or coded language, and then whether dialect is part of that story.
Mm-hmm.
Yeah, so I think this also relates to Jeff's earlier question. I think this need to come from like a real world user needs. So if there is a community that could benefit from having AI with this specific identity, then definitely that's a great need. But I can also see a lot of scenarios where this type of like AI-specific markers may be problematic. And if we just like take a step back or like remove the dialect layer, if we just think about like whether AI should have their identity, I think there are a lot of research in terms of how a specific identity of AI might affect how people perceive it. So something very lightweighted where researchers in HCI community did is once they replace like conversational agent today, we have an icon in terms of like a robot, and then that's how people perceive the image of a conversational agent. And this research team replace it with an animal, with a plant, with a flower, with all sorts of things, and then see how people perceive the authority and the engage, like I guess like usefulness and a lot of other aspects change. So that's more from a visual perspective. I would imagine that if we give it a different language-based identity, it may have like different type of perceptions. I don't see any research in that space, but I think definitely something very interesting to kind of explore.
I'll work with you on that. I love it. Okay, I'm going to take the last little few minutes because I want to ask you a provocative question. Everybody in this room writes for a living and does analysis, some empirical, some legal, some policy. And I kind of wonder if in the future they'll look back and be like, oh, before 2023 or 2025, let's say, give a year or two, isn't it cool how they all wrote their own stuff and they did their own human annotation and they paid people to do coding and rating and stuff like that. And that us in the room are just sort of sitting here pretending like that's not all about to change. Like I have this really strong feeling with my students that that last paper that I just finished writing is like the last paper I'm going to write, right? And I see all your human annotation stuff, like LLMs, why have 2 coders and an LLM? Why not have 3 LLMs, right? And why will we write our papers when these can do it? And why would I read them when it can be synthesized and summarized by an AI? Like our whole practice, I feel like, is deeply at risk. And maybe for good reasons, maybe it'll be better on the other side. But I feel like we're kind of pretending like nothing's changing for all of us that just write and analyze intellectual stuff. Like that's what this system you just showed is amazing at. So what's your reaction there? I'm worried. But I have tenure, so it's all good.
Okay.
Yeah, I know.
Okay, now I feel pressured. So on one side, I share similar sentiment. I start to view, this is like the change that I see with myself. Last year, I think I was still the attitude that, no, this AI is not doing great, like see this hallucination, see this issue, etc., etc. Well, we are still like actively working on making them better, but I do see creative and everyday use of those systems. For example, these days, my friend, not me, let's see if she wants to write, if she wants to write an article, you can decompose the task into smaller pieces where you could see like, oh, write a broader impact for this technology I'm going to build. It can give you a very nice written broader impact. You could also see like, okay, write this broader impact so that it sounds very attractive to this specific agency. And it can do a very good job at personalization. So this kind of align with your concern that why do we need to write? If we could even have a very intelligent AI that can decompose a very complicated task into smaller ones, and for each smaller task, another intelligent AI can do the smaller task very well, then it seems we could have a plausible article in the end. So this is one side of the story. On the other side, I think it also puts more responsibility on human, because we need to be held accountable for what we produce. And we all know that hallucination is one issue. So let's say if it tells me like, oh, you need to set these 3 papers from Jeff. Yeah. And if I do a careful search, none of them exist.
Right.
Yes. So in this way, I may be setting something that are not verifiable.
Right.
Or in those cases. So I feel like it will also put a more responsibility to human to verify and then to probably like post-edit of what's existing there. So that's one thing.
So in your view, it's like it does all the work and we're like the responsible agent. Like there's the lawyer that created case law that didn't exist. He's in deep trouble now. So we could be like, well, we didn't check our GPG-generated paper closely enough, and now we're going to be sanctioned or something. Because it could also do everything else, right? Like, why should I go and collect data with real humans? I could get GPT to simulate 1,000 people and then code it.
So this is something I'm going to mention next. So
okay.
I definitely think that's what I mentioned right now, like we need to be held accountable is the first level. The second level is something deeper. I wonder how it influences the diversity and the homogenization of our knowledge creation process. Let's say if you write your article towards socially responsible NLP in ChatGPT, and I write my article on socially responsible NLP in ChatGPT, we may end up with similar viewpoint. We may end up with similar knowledge. Like in this way, if you put it long term, who is going to produce creative and unique knowledge for the world? Who is going to drive the breakthrough? I think a lot of the breakthrough, at least from my personal background of reading different articles, seems to be like people from like very diverse interdisciplinary background. They come up with something unique that drive the next big breakthrough. If everyone is going to rely on this type of thing, then I wonder whether that's going to be a boost or a drawback of our intellectual creativity, diversity, and how that might affect the knowledge creation process. And even if you think about like a viewpoint, if we are going to just express our attitude towards New York Times or articles by using ChatGPT, like, hey, write me a view against this opinion, and then everyone's going to be similar in that way. So I think that's some deeper things we need to be aware of as well.
Great. Well, thank you so much, Dee. It's fantastic.
Thanks.
Feel free to reach out to DE if you have any more questions. Join us next week. Very excited to have Candace Odgers here. For those of you that saw the Surgeon General's report that came out last week about social media and mental health for young people, Candace's work was central to that. That came out. I think she's one of the most reasoned and thoughtful people about social media and adolescents. So I encourage you to attend if you can. Thank you again, Dee, and take care.